1-6 worksheet. 1-6 worksheet, problems 1 through 6. How do I first determine if something has an inverse?
That's
not 9. I'm sorry?
the horizontal line.
If it passes the horizontal line test, because if it passes the horizontal line test, then it is a one-to-one function, correct? Since it's a one-to-one function, we know it has an inverse. So what do I want to do? Problems 1 through 6. Who has one that they'd like me to go over? Number 2. G of x is equal to negative square root of x minus 8. Now, how do I determine without graphing this if this thing has an inverse? I need to know if it's going to pass the horizontal line test. So in order for me to do that quickly and effectively, how do I do that? I need to say, well, what's my parent function? We have several different parent functions. C, which is a horizontal line. X, which is a line with slope positive or negative. And our parabola, which is x squared. Our spaghetti function, which is x cubed. Our absolute value function, which is a b. And then our last one, the square root of x, which is the one-armed bandit, right? Okay? So now with that said, can you tell me which function is this, which one is the parent function for this? The square root of x. So does that pass the one-to-one, the horizontal line test? It's a one-to-one function. Yes, so now I know this thing has an inverse. So since I know it has an inverse, yes, it's one-to-one. Okay? Because it passes the horizontal line test. I know the parent function. Now I need to find the inverse. So how do I go about finding the inverse? Step 1. Y is equal to the square root, negative square root of x minus 8. Swap x and y, so this is x is equal to negative square root of y minus 8. Solve for y. Booker, this is all you, man. So what do? Divide by negative, right? So negative x is equal to the square root of y minus 8. Now what? The opposite of the square root is a square. So I'm going to square both sides. The negative x times negative x is x squared is equal to y minus 8. The reason why it's y minus 8 is because why? I took the square root off. Very good. Now, keep going. Not 8. So now G inverse of x is equal to x squared plus 8. Now, I got a question for you. Is x squared plus 8, does it have an inverse? It does? What does x squared plus 8 look like? It's a parabola. Does a parabola pass the horizontal line test? No. So technically, I would have to restrict this domain for it to be the parent function, correct? Do we understand that? Now, what I want you to understand here is if I have g of x is equal to negative the square root of x minus 8, what happens to that graph? It's reflected down over the x, and it's shifted which direction? To the right 8. So what I have looking like here is going to be 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be reflected. It does normally look like this, so it's going to look like that. Do we see that? Yes or no? Okay? So if I want this to be a one-to-one function, I want these two functions to be inverses. I need to do what to the domain of the inverse? Because this is going to be all the way up here. Right? That's the parabola. That's not true, right? So I only want that part of it. So what am I going to do to that? What's the restriction going to be? What's the restriction? X has to be greater than or equal to 0. 0. 0. Because that's the y value. Here's x equals 0. You with me? Okay? So this is what I'm actually looking for here. That would be inverses. Because we've got to restrict that domain a little bit. Okay? Am I going to be that picky on the test tomorrow? I may give extra credit if somebody gives me that. If you don't do it, I'm not going to call you out on it. But if you do it, I'm going to give you extra credit for it.
Would you put?
You do it.
Would you put an x as the element of reals or?
No, because you're just going to put a comma here.
If we get it wrong, you might do it.
Nope.
Is there a domain restriction for every problem?
Only if it does not pass horizontal line test.
Okay.
Like if you're looking at our parent function, This does not pass the horizontal line test, and this does not pass the horizontal line test. Absolute value and square and x squared do not pass the horizontal line test. So therefore, if you're doing an inverse of those things, you have to make sure that the inverse does pass the horizontal line test, which is why I restricted it. Does that make sense? And another good check, they're reflections, correct? They're reflections. Okay, do we see that? If you didn't restrict it, you'd still have this other arm hanging out there, and that would not be a reflection of it, would it? Do we all get that, yay or nay? Okay, excellent. Moving right along. Are we good on that then, on that section, 1 through 6? Okay, go to the next section, problems 7 through 10. Do I have any questions over 7 through 10? Directions say, given two functions, f of x and g of x, prove that they are inverses by doing f of g of x equals x and g of f of x equals x. Did they all pan out to be? Yeah. Did everybody get yes? It says to prove, so I'm assuming that yes, they did. I don't know where my answer key is. Yes, they did. They all panned out. Alex? Okay, any other questions? On 7 through 10, we're good? Okay, go to the next batch on that one. 11 through 14. It says find the inverse of the function algebraically and then determine if f of f inverse of g of f is equal to x and if f inverse of f of x is equal to x. What the world does that mean? I want to do problem 13. Did anybody struggle with 13? 13? You struggled with all of them? F of x is equal to 6 divided by the square root of x. 6 divided by the square root of x. Now, what it asks you to do is what? Find the inverse. Okay, so now what we're going to do is they're saying that the inverse exists. I don't even have to check to see if it passes the horizontal line test, correct? They're saying it does exist. So what I'm going to do immediately is I'm going to take f of x turns into y. Now what do I do? So x is equal to 6 over the square root of y. I'm going to cross multiply, which is exactly the same thing as what you just said. So when you cross multiply, you're going to get exactly the same concept. What am I solving for? I'm solving for y. So what's attached to the y that I need to get rid of? Nope, not yet. I need to get rid of that x times x. So how do I get rid of it? Divide by x. So I have the square root of y is equal to 6 over x. Now how do I get rid of that square root? Square. So I'm going to square both sides. So that's going to give me y is equal to 6 squared over x squared, which is going to give me y is equal to 36 over x squared. Now what is y in this case? So f inverse of x is equal to 36 over x squared. So there's the inverse. I found it algebraically. Do we all understand that? Okay, now what's the next part of it say to do? Then prove that they're inverses. So I have f of x is equal to 6 over the square root of x, and then I have f inverse of x that I calculated to be 36 over x squared. Do we all see that, yay or nay? So if I've calculated that to be that, now I need to prove that these two are actually going to be inverses of each other. So how do I go about doing that? I need to do the composition, f of f inverse of x. Now what is f inverse? That means I'm doing f at 36 divided by x squared. Do we see that? No. Now what is f defined to be? 6 divided by the square root of x. Right? Every time I see an x, what am I plugging in? Do we see that, yes or no? First of all, how many of you are looking at that saying that is god-awful ugly? Right? So let's write it in a method that isn't gonna freak you out. So this is going to be 6 divided by the square root of 36 divided by the square root of x squared. What's the square root of 36? What is the square root of x squared? So now When you divide by a fraction, what are you actually doing? Multiplying by its reciprocal. So what happens to my 6's? And I'm left with x. Are they inverses? Yes. I proved that just now, didn't I? Why did I do this problem? I like this problem. Because there's a whole lot of ugliness going on there. There's a whole lot of things that you got to remember from Algebra 2. Correct? I expect it to be on there tomorrow. Okay, any questions? Okay, on the back side of the matching, how do we do on the matching? Number 15, what's its match to number 15? A, very good. Number 16, what's its match? C, number 17, what's its match? What is it? B as in boy or D as in dog? It is what?
She's saying D.
B as in boy.
I say D as in dog. Okay? And number 18, what's that one going to be? B. Okay? All right. Now, that is 1-6 section. That's all going to be on the test tomorrow. Now, tell me this. When do you have an inverse?
Passes the horizontal.
The passes the horizontal line test. Remember, to be passing the horizontal line test, I asked what's your favorite ice cream? And lovely old Colton here said that it was just going to be vanilla. So nobody else was able to get vanilla ice cream because that was his tub. Remember that? In order to be a one-to-one function, everyone, you must choose only one y value. And every one y value, you can only choose one x value. You understand that? So if I'm giving it to you as a relation, you need to check those mappings. Okay? Now, the last thing we need to talk about is going to be 1-7.
Can we do the third problem?
That was the only problem you had left to do, was the third problem.
Seriously, I did not understand.
Which one were you going to try and do? If we,
The second one, because you did the first one.
What?
It doesn't have to horizontal line test. So you try to find it on grade 3.
No.
Okay. So 6. We didn't have to do that.
6 does not pass the horizontal line test. You do not do that. Okay? Okay.
Does the topic do
Because it's squared. Okay, I'm going to create a new document here, and I need to do number problem number 3. The table shows the average salary S in millions of dollars for professional baseball players from 2001 to 2007. Just complete a scatter plot on the calculator of the above information, letting T equaling 1 to the year 2001. So what do I need to do first? List and spreadsheet. So what do I label column A to be?
your Y?
Focus, guys.
You put your Y in there.
You can make it whatever you want. I'm going to just hit Y for year because actually no, I'm going to type it out. Yes, Zach. Top Ben. Yep, you need 2 things. You should have been, did you get the regression steps on Thursday?
Yeah.
Okay, then the worksheet's underneath the regression steps. Okay, so year. The first thing I'm going to put, 2001 corresponds to what number? So I have 1, then what? 2, 3, 4, 5, 6, and 7. How do I get up to the top of my graph? Control 7 takes me up to the top of my data. Come over here to column B. What's that going to be? Salary. Salary is lower than I like it.
Are you saying celery or salary?
Salary.
She said celery. She didn't say
Okay. Now, my salary is 1.7 mil, 1.8 mil, 2.6 mil, which a professional baseball player, anybody professional should never make this much money, just saying. Use your brain. Okay, after you enter your data, what should you always do? Check for what? Errors in data entry and that the dimensions are the same. So I'm going to assume that we're good to go as I'm checking. I am. Okay, so now what do I do? Control doc. Control doc, I'm going to do a graphs page. However, I'm on function notation here. Do I want function notation? What do I want? We did, but I'm going to just take this route because this is where we're going to do everything out. Okay? Over here, I'm going to do graph type. I'm going to do scatter plot. So my scatter plot, what do I use for my year? Or my X is going to be year, sorry. Totally just gave you that. And then Y. And hit enter. Now, what does it look like? Can I see it nicely? What if you can't see it nicely? What should you do? Menu, zoom, data. And you can see it. Now, it looks different blown up, doesn't it? Looks a little different blown up. Okay? Can you tell me, what type of model is this going to be? It's going to be a positive regression model, positive correlation. Is it going to be strong? Probably not the strongest because what we have going on, there's a little bit outliers there. Now, I want to talk about those outliers. Remember, you're talking baseball. Why would we have differences in salaries not being consistently linear? What would change that? Skill? What else? What do you mean average? Batting averages. In other words, how well are they performing? Would be another one. What team they're playing for? Did they win the year before? Did they have a really good winning record? Did they? Were they World Series champions? Okay, things of that nature. That could affect it. So those are things that we mathematically cannot calculate. Booker, are you good? Okay, so letter A, does the graph information appear to be linear? Yes, it does appear to be linear. It is going in an uphill battle. I can actually draw a line here, and it's going to have a positive slope line. We all understand that. Letter B, since I look at the scatter plot, what type of correlation does this information have? Positive. Is it going to be a strong one? Probably not. Letter C, find a regression model. How do I do that? No. Control doc, I need a new page, and what type of page do I want? No. Calculator page. So I want a calculator page, and I'm going to hit menu. What do I want to calculate? Statistics, stat calculations, mx plus b. What's my x going to be? Arrow to the right, drop down to year, arrow to the right, drop down to salary. What's the F1 mean? Then I'm storing my function, my linear regression function in F1. And hit OK. It's not the calculator, it's the operator test. It only does what your fingers tell it to. Now, here is my M and my B, and I also have R. What's important on here? Letter D, what is my R value? 0.95. Now, that's not really weak. It's not the strongest, right? Okay? So it's going to be a good correlation. It's not going to be real bad. I can do a good future prediction on it. It's not having too big of an issue. Okay, so now I go back to 1.2. It's not there. Why? Because I only have my scatter plot. So if I hit tab, I'm on S2. What's that mean? I need to go where to get my function notation? Menu? Graph type? Function. Why does it put me to F2? Because there's already something in F1, arrow up, and hit enter. Shebang. There she is. Now, this is the function you write down on letter C. Do we all understand that? This is the function you write down on letter C. Yes, Matt?
Arrow up.
The function would have been already there whenever you did your regression. Arrow up and enter. Here. Now, are we all listening? You have to do regression every chapter. This is the only chapter I'm going to allow you guys to use your regression steps. Next chapter, when we do regression, no steps, it's pure memorization. Am I clear on this? Don't come tomorrow with the test and say, oh, I forgot my regression steps. Can I have another copy, Mrs. Gear? No, not your mama, not your filing system. Bring your own steps. Yes.
For C, you put the longer one because it's longer.
I will accept either one. Okay? Now, he's saying, why am I putting this one? And this one looks pretty clear. Okay? Now, in the event that it has scientific notation or exponential notation there, then obviously I want you to hit tab and I want you to arrow up, and I want you to round this one off. But again, these ones rounded are going to be equivalent. Do you understand the difference, Booker? Okay. So, now with that said, are we all good on that? Now, letter E, it says use the model to find the year in which the number, E, interpret the slope of the model in the context of the problem. What in the world is going on with this slope? Slope is 0.364. What is that? What is slope graphically? What is slope graphically? Rise or run. What does this mean? What's my rise? What's my run? My run is my y values. What's my y values? Come on, what should I tell my y-axis to be? Salary. So that's going to be the change in the salary over the year that you have. So that is going to be what? Interpret it. What does that mean? It's the salary increase. It's the change in the percent of the increase from year to year. We understand that. Letter F. Use the model to find the average salary for the professional baseball player in 2010. So if 1 is 2001, 2 is 2, 3 is 2003, 4, what's 2010 going to be? What's 2010 going to be? That was hard. That was a trick question. Okay. Use the model to find the average salary for the professional baseball player in 2010. How do I do this? Remember, I showed you 3 different methods. You can control T. You can control T, and you can get it directly out of your table by arrowing down. Or I can go back over to my calculator page and I can do what? F1 parentheses 10. Do you remember that? And hit enter. And what's my average salary for a baseball player in 2010? 4.88 million, about 4.9 million, right? Ridiculous. Just. Letter G, use model to find the average salary for professional baseball in 2012. Well, what's that going to be? F1 parentheses 12. Enter. So an average baseball player is going to be making $5.6 million this year. Does this salary represent the salary of today's players? They do not make $100 million. Why or why not? Does it represent today's baseball players, you think?
It's pretty accurate for baseball.
It's pretty close right now, but tell me this. What about in year 2040? Is it going to be pretty accurate as how much you're going to make then? No, it's continuing to increase to the point where they're going to be making, okay, let's do 40, 2040. Let's do F1.
Oh, yeah.
F1, parentheses 40. Are they really going to make $15.8 million?
Probably.
If they make that much money in 1 year, as a baseball player,
Josh Hamilton makes 52 million in 4 years.
I strongly disagree. I agree with Sierra. This is going to eventually notch off. So basically what you could have as a function like this could be the one-armed bandit function, right? Probably a logarithm would probably be a better estimation for something like this. But, okay, so do we understand that because this is a linear function, it's going to constantly grow to the point where later on it's not going to be a good estimation? Okay. What did I just say? For that year, it is a good estimation, but for later future predictions, like in the 40s, year 2040, year 2050, it's probably not going to be. Why not? Because it's going to be linear. It's going to keep growing. Well, yeah. Do you really think that somebody's going to make $100 million in one season just as fast?
Yes.
No.
If Babe Ruth was still alive, he'd be making more than that.
Okay. Now.
He was on a $99 million contract. That was a 4-year contract.
Now, are we good on what to expect for tomorrow's quiz or test?
So we got what's E?
E. What was E?
Interpret the slope of the
Salary
model.
increase.
Salary increase, yearly increase. Okay. Any questions? Okay. Now, what I'm going to do, test is tomorrow. Study tonight. I'm going to call you guys up individually, and I'm going to show you what your grades are. Okay? And I'm doing this for a very specific reason because some of you actually need
Mine's F because I need to take the test.